In my previous video, we saw that second derivative equal to 0 does not guarantee a point of inflection. So the question is, what does the second derivative actually tells us? Hello everyone, welcome back to Olsen Cafe. Today we are going to learn how to use second derivative test to determine the nature of points. That is, to determine whether it is a maximum or a minimum point. So before we begin, let us take a look at the condition for the second derivative test. So over here, we have second derivative less than 0, and this will give us a maximum turning point. And similarly, if we have a second derivative that is greater than 0, then this will give us a minimum turning point. So in this video, we are going to use this function y equal to x squared times x minus 2 squared to determine the nature of the turning points. So we are going to start off with finding the first derivative and the second derivative of these functions here. So you can see it is a product of two terms. So what we are going to do is we are going to apply product rule over here. So using product rule, we are going to have u dv dx plus v du dx. And by simplifying these expressions here, we are going to derive at 4x times x minus 1 times x minus 2. So you can give it a try and see if you are able to simplify till we get this term. Now, so we are going to find the second derivative. And to do this, you can see that there's a product of three terms. So to simplify our working, so what I am going to do is I'm going to expand this and make it into the product of two terms. And using this, again, I am going to use product rule, all right, to find the second derivative. So you can pause the video and try to work it out and see if you are able to get the expression that is same as mine. So I will get 4x times x minus 1 plus 4x times x minus 2 times 2x minus 1. So at this point, I will just leave it as it is here, and I'm going to move on to determine whether it is a maximum or the minimum turning point. But before we can do that, what we need to do is we need to set dy dx equals to 0 to find the stationary point. So to do this, I focus on my dy dx over here. As you can see, I have three terms, which means I have 4x, I have x minus 1, I have x minus 2. By equating this equals to 0, I will be able to get three stationary points, which is x equals to 0, x equals to 1, and x equals to 2. So with these three turning points, I am going to determine the nature of the point. So what I am going to do is to make use of the second derivative. So what I'm going to do is to substitute the points into my second derivative and then to see what is the value that we will be able to get from here. So let's take a look at x equals to 0. So by substituting this into the second derivative, I will be able to get this equals to 8. Alright, so you can see 0, so this term gives you 0. So if I have 0 here and 0, so I multiply them together, I will get 8. So since second derivative is greater than 0, then therefore I can conclude that this will give us a minimum turning point. So similarly, if I am going to substitute x equals to 1 into the second derivative, so I will get second derivative equals to negative 4. And since this is less than 0, hence I can conclude that at this point x equals to 1, this will give us a maximum turning point. So I'm going to do the same thing and repeat and sub x equals to 2 into the second derivative. And you will notice that you will again get second derivative equals to 8. So with this, I can conclude that x equals to 2 will give us a minimum turning point. In summary, if you want to determine the nature of the turning point using the second derivative test, what we need to do first, is to set dy dx equals to 0 to find the stationary point. And then what we need to do is to find the second derivative. And if it is less than 0, then from here we can conclude that this will give us a maximum turning point. And if second derivative is greater than 0, then this will give us a minimum turning point. But do take note, as I mentioned in my previous video, the moment if you have second derivative is equal to 0, do bear in mind, in this case, it is not conclusive. You cannot just simply jump into conclusion and assume that this will be a point of inflection. In fact, in my previous video, I mentioned that in such case, we will need to apply the first derivative test to determine the nature of the point. It could be either a maximum, minimum point, or a point of inflection. So if you have yet to watch my previous video, please do so. Thank you for watching this video. I hope you found this useful. If this helped you, please like and share the video. See you in my next lesson. Bye.